Question 4 says, what element has its 4 highest energy electrons in the 3D orbital? Okay, that's complicated, doesn't make sense. What we're saying is the final 4 electrons should be in the 3D orbital, or it should end in 3D4. Once again, I can write all of the ones that would precede the 3D and fill this up and count how many electrons and determine what element it is. Or if I'm using the blocks in the periodic table, I can look here. So let's first do the blocks of the periodic table. So I'm looking at my D block. Group period 4 contains the 3D block. And then I'm going to look for the 4th one into the block. 1st, 2nd, 3rd, 4th. So this should be chromium. Let's go ahead and do it the long way, just in case. I know I have to fill everything up to the 3D, and the 3D would just have 4. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. I have 1s, 2s, 2p, 3s, 3p, 4s, and these are my remaining 4. And now I add up the number of electrons. 10, 2, 6, 2 is another 10, and 4. So 24. 24 electrons is also 24 protons is the atomic number of chromium. Either way, I'm going to get chromium. Write the electron configuration for iodine. Oh, I just did that on the other slide, didn't I? Iodine. It has 53 electrons. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10, 4p6, 5s2, 4d10, 5p, that's again, 4 and 6 is 10, that's another 10, that's 20, that's 30, 36, 38, 48, I have 5 left, 5p5. Also, if I'm using the strategy of the periodic table, I recognize that iodine is located in the 5th period, and it's in the p block, and it's the 5th one in the 5th column of the p block, so I know it's going to end in 5p5, and then I just write all the ones that, all the orbitals below, lower in energy than 5p, and write them as being filled. And the last one is kind of just reminding us about seeing if you know anything about potential energy, which has more potential energy: 2 protons, 1 electron, 1 picometer apart. Or 3 protons, 1 electron, 1 picometer apart. So I have a positive and a negative. Positive 2, negative 1, 1 picometer apart. Or positive 3, negative 1, 1 picometer apart. They're the same distance apart, so distance doesn't have anything to do with this. But it is important to understand that distance affects the strength of attraction, and of course it affects the potential energy, and so does the number of protons. So I would have 3 protons would be a +3 charge, and a +3 charge is going to be a bigger charge, and therefore it has more attracting power between it and an electron than one with just 2. So this one would have more potential energy because it took more energy to separate them that 1 picometer apart, because they were tightly attracted.